Here's a walkthrough on how to find the area and perimeter of polygons on a coordinate axis. For the very first question, it's asking us to find the area of a triangle. Now that can be done a couple different ways. The quickest route sometimes can be to find the base and the height and to use the famous formula, area equals 1/2 base times height. The only thing is, bases and heights have to be perpendicular to each other. So the height of a triangle, or the height of any shape, must be perpendicular, or must make 90 degrees with the base. So we're not allowed to use that formula unless we have the right ingredients. Luckily for us, in question number 1, we have the right ingredients. Because in question number 1, if we count this side, AC, as the base, we can use side BC as the height. They look like they form 90-degree angles. I mean, a sheet of paper can actually make you feel like it's probably 90 degrees. A corner of a piece of paper is worth 90 degrees. But you can also tell it's perpendicular because the slopes are negative reciprocals. The slope of AC is up 2 over 3. The slope of BC is down 3 over 2. Down 3 over 2. Those are negative reciprocals, so those are the height and the base. All right, so let's find how long the height is and how long the base is. So the base is crooked. I'd have to use the Pythagorean theorem to figure it out. So if I want to find out how far it is from A to C, I could count vertically that's 4 spaces, horizontally 2, 4, 6 spaces, and I could use the Pythagorean theorem or that Pythagorean trick that I showed you, that AC would be the square root of 4 squared plus 6 squared, which would be radical 40. And I could do the same thing to find the height BC. So BC is going crooked. I would have to count that BC is down 1, 2, 3, 4, 5, 6, 7, 8, 9, and over 1, 2, 3, 4, 5, 6. And I could use those numbers in the Pythagorean theorem or use them under the radical like so. So that would give me 81 plus 36, which is the square root of 117. All that's left to do is use the formula. Area is half base times height. The base was radical 117. The height was radical 40. It doesn't say how to leave the final answer. That would be the exact answer right there. But if we used a calculator and typed this into the calculator, making sure that we put in parentheses around the 117 and the 40, you would get it to the nearest tenth at 34.2 for the area. All right, so some more practice on one more question, and then you should be ready to do some work on your own. Okay, for a question like number 2, this one's asking you to find the area of the kite and the perimeter in simplest radical form. The way that the kite is laid out here, there are 2 ways to work the question out. Maybe the quickest way is to take this kite and split it right down the middle and find the area of both parts. Both of these triangles are congruent to each other, so you could find the answer by using the formula area is half base times height and counting up how long the base is, which would be that blue segment, and then figure out how tall the shape is, that would be the height there in green. So it's a very quick answer if you tackle the question this way. You get the area is equal to half of the base, which if I count it up, comes out to be 5, 6, 7, 8, 9. So half of 9 times the height. The height is 1, 2, 3. So altogether I get half of 27, which ends up being 13 and a half for the area. All right, switching gears and getting into the perimeter. To find the perimeter of this kite, I'd have to go all the way around and find out the length of all four sides. Let me label some of these sides so they're easier to talk about. We'll call that side AB, this other side BC, and CD and AD. So I have to find four lengths and add them together. The good news is that AB is the same length as AD. And also, BC is the same as CD. This is because it's a kite. It's going to have those properties where those sides are the same. So if I just find out how far it is from A to B, then I'd have the other one, A to D, at the same time. So to find out how far it's from A to B, I can use the same method I used for the first question and use the Pythagorean theorem to figure it out. This is up 3 spaces over 7. So I can use the numbers 3 and 7 under the radical to find out how long it is. So 49 plus 9, and we're going to end up getting radical 58 for how far it is for those two. Sides. For BC, it's the same thing as CD, and I can use the Pythagorean theorem there using the numbers 2 and 3. So I'll end up getting 2 squared plus 3 squared, which is 9 and 4, which gives me a total of radical 13. So if I want the perimeter would be equal to radical 58 plus another radical 58 plus a radical 13 plus another radical 13. It says to write it in simplest radical form, so I'm going to have to find a way to break down these radicals. And the way to do that is to use a factor tree. If I try to break down radical 58, I can start by dividing it by 2, which is 2 times 29. Now 29 is a prime number, and that's the end of my factor tree. There's no way to break down radical 58 into smaller pieces. I can try to do the same thing for radical 13, but I'm not going to find any number except for 1 and 13 that multiply to make 13. 13 is a prime number. So in this case, there's no way to break down the radicals, but I can simplify them together by saying that there are 2 radical 58s and there are 2 radical 13s for the total perimeter. And that's in simplest radical form. Now you could type that into the calculator to see what the answer looks like and to make sure that it's not an outrageous answer. The perimeter comes out to be approximately 22.4 spaces, which, if I take a look at the original picture, it's believable that all the way around the shape would be 24. Okay, and then just one more thing to show. Here's one last example to show you that sometimes you can't rely on just using half base times height to find the area of a triangle. So let's suppose I wanted to find the area of this triangle. And I'm like, oh, it's easy. It's base times the height divided by 2. If I call this one side the base here, I'm going to need to find the height somehow. So I'm going to need to figure out how long it is from here to here, which can be kind of complicated. You'd have to use a really bizarre formula to do that, and it's much easier to rely on some basic skills instead. So you can see that this one, to find the yellow height, would be difficult to do. None of these sides are perpendicular to each other, so I'd have to try to rely on a different method to get the final answer. So this is what you'd have to do instead of using just area as half base times height, is a skill that some people like to say, or some teachers like to say, is to box the shape and use the blue box along with these 3 triangles to figure out the total area. So to figure out the area of that black triangle, I'd have to find the blue box, and I'd have to take away the red triangle, take away the yellow triangle, and take away the blue triangle. To find the area of the blue box, it would be just base times height, which would be 4 times 7. 4 times 7 is just 28. And I didn't want to know the area of the entire box. I wanted to know just the triangle in the middle. So I got to take away the red triangle, which is half the base times the height. So for the red triangle, it's half of 2 times 7, which would be worth 7. The area of the yellow triangle would be half of the base of the yellow triangle, which could be counted as 4. And the height of the yellow triangle could be counted as 4 as well. So half of 4 times 4 would be half of 16, which is 8. So the yellow triangle is worth 8 spaces. And then finally the blue triangle is the smallest one, it looks like. It's got a base of 2 and a height of 3. So I would do minus half of 3 times 2, which would be half of 6, or 3. So the overall area would be 28, take away 7, take away 8, take away 3, which ends up being worth 10 for the area. Well, I hope this video helped organize your thoughts, and now you're ready to tackle the questions that I've given you to do.